Hey there, and welcome to the team. I'm seriously thrilled to have you on board. Since you're just getting settled in as our newest junior developer, I figured, hey, let's jump right into a quick, friendly one-on-one code review session. Don't sweat it, this isn't a test or anything. This explainer is just about looking at how we write code and finding ways to make it, well, cleaner, faster, and honestly, just a whole lot more fun to write. Today, we're going to zero in on something absolutely fundamental to programming, something that actually gives our code a rhythm. We're going to master the art of loops.
Okay, let's dive right into this. We're looking at your recent commit here, and, well, we've got 10 identical lines of print hello world stacked right on top of each other. Now, I just want to gently point out that writing the exact same statement over and over, yeah, that's a pretty painful way to code. I mean, imagine if the project manager asked you to print it 100 times, or, no way, 1,000 times. You'd be sitting there copying and pasting literally all day. But take a look at this concise little 3-line block of code instead. It's called a for loop. It accomplishes the exact same thing, but man, it does it with such incredible elegance. The whole reason we lean towards that concise approach really comes down to the golden rule of clean coding. It's called the DRY principle. DRY stands for do not repeat yourself. You know, in professional software development, whenever you catch yourself copying and pasting the exact same logic, a massive alarm bell should go off in your head. Every single piece of repetitive code just adds complexity and makes your work so much harder to maintain down the line. By sticking to the DRY principle, we're basically letting the computer do the heavy lifting for us. Because let's be real, computers are quite literally built to handle massive repetitive tasks without ever breaking a sweat. So how do we actually stop repeating ourselves? Well, we use a loop. But what is a loop, really? At its core, loops are just instructions that repeat. Think about it. Humans, we get tired. If I asked you to handwrite hello world 1,000,000 times, you'd probably quit right now, right? But computers, they absolutely love to repeat things. They will execute that exact same instruction endlessly, perfectly, and they never, ever get bored. A loop is essentially just our way of telling the computer exactly what we want it to repeat and exactly how long to keep doing it. Let's step away from the code editor for a second to really lock this in. Imagine you've got a robot friend, okay? And you want to teach this robot to climb a flight of stairs. You can't just yell, hey, go climb those stairs, because it has no idea what that means. You have to be highly, highly specific. You need to give it a rhythmic sequence of instructions. So you tell it, left leg up, forward down, right leg up, forward down, left leg up, forward down, right leg up, forward down. See what's happening? You're establishing a rhythm, a beat for the robot to step to. But just like with your code commit, you're saying a whole lot of the exact same things over and over again. And this brilliantly illustrates exactly why we need a better way to communicate with our machines. Instead of writing out every single tiny step for, say, 50 stairs, we just set up a loop. We take the action, that whole sequence of leg up, forward, down, and we place it inside the loop, writing it just one single time. Once that sequence is packed inside, there's really only one thing left to figure out. We just have to tell the loop how many times to repeat. That is literally it. The loop takes our single instruction block and plays it back as many times as we tell it to. Right, so let's translate that robot stair-climbing logic back into actual C programming syntax. To set up your standard for loop, you're going to need 3 essential ingredients. You've got initialization, condition, and increment. Honestly, think of these 3 parts like you're setting up the musical beat for your code. They dictate exactly how the song starts, how long the song is going to play, and the tempo of every single beat. Let's break down exactly what each of these 3 crucial steps is doing behind the scenes. Now, what's really interesting about this first step is just how simple it actually is. Step 1 is initialization. In your code, this usually looks something like int I equals 1. So what's actually happening here? Well, imagine you're creating a tiny little cardboard box in the computer's memory. You labeled that box I, and you drop the number 1 right inside it. This little box, it keeps track of where our loop begins. It is the very first downbeat of our song, and we only create this starting box once, right at the very beginning, just to set the stage for our repeating rhythm. So once we have our starting beat, we definitely need to know when the song is supposed to end, right? That brings us to step 2, the condition. Here, we're looking at I less than or equal to 5, which translates to while our box I is less than or equal to 5. This is the absolute strict rule that tells the computer exactly when to stop running. Every single time, right before the computer repeats our instructions, it checks this rule. As long as this statement holds true, the music keeps playing, the loop keeps looping. But the very second it becomes false, like say our box I hits the number 6, boom, the music stops instantly and the loop is completely over. Finally, we arrive at step 3, the increment, or, you might hear some of the senior devs around here call it the updation step. This one usually looks like I++, which is really just a fancy shorthand way of saying I equals I plus 1. This is the gear that actually moves us forward to the next beat. After our computer plays through one round of the loop, it visits this increment step and adds 1 to our starting box. So our 1 becomes a 2, our 2 becomes a 3, and so on. Without this specific step, our box would just stay at 1 forever. The condition would literally never fail, and our code would be trapped in an infinite, never-ending loop. And trust me, we do not want that.
Let's pull it all together and see how this builds a continuous, repeating rhythm right inside the computer's brain. Once that initial starting box is created, the computer falls into a really strict 1, 2, 3 waltz. Step 1, check the condition. Is I less than our limit? If yes, keep going. Step 2, go inside the loop. Execute whatever code is sitting in there. Step 3, updation. Add 1 to our I box. And then the rhythm just repeats. Check condition, go inside, update. Check condition, go inside, update. This whole rhythm continues flawlessly until that condition check finally fails. And you know what the best part is? That go inside step can hold as many instructions as you could possibly want. Let's go back to our robot for a second. Maybe we want to add a little flair to its stair climbing, right? We can program the loop so that after left leg up, forward, down, and right leg up, forward, down, the robot actually shouts, hooray! Because we put everything inside that one loop block, the robot will execute the climbing sequence and shout hooray on every single step it takes. Whatever you pack inside that loop block gets repeated perfectly every time.
All right, Mentee, it is officially challenge time. We've talked about the dry principle, we've explored the rhythm of initialization, condition, and increment, and we know exactly how to place instructions inside the loop itself. So I want you to mentally look back at those 10 messy, repetitive lines of print hello world that you wrote earlier. Based on everything we just discussed, how would you combine this new knowledge to replace that whole block of repetition into one elegant loop? Just take a quick second here to visualize what that syntax would look like.
So here is the crucial point, the solution. Let's actually read it out together. For int I equals 1, I less than or equal to 10, I plus plus, boom. We created our starting box at 1. We set our condition to stop after 10. We set our increment to step up by 1 each time. And right there, inside the curly braces, we simply wrote print hello world exactly 1 time. By setting up this perfect little loop rhythm, the computer is going to check, print, and update exactly 10 times. You've literally just turned 10 clunky lines of code into one clean, manageable, and highly professional block. Real game changer, right? Before we wrap up this one-on-one session, I want to leave you with this one thought. If a basic loop can turn 10 lines of code into one, just imagine what it does when you're dealing with a million lines of data. I mean, imagine processing thousands of user profiles, calculating massive mathematical series, or animating complex graphics, all managed by simply tweaking a single number inside your condition block. That is the immense, absolutely awe-inspiring power of automation that loops unlock for you. So, Junior Dev, the only question remaining is, what will you automate next? Thanks for joining me for this explainer. I seriously cannot wait to see your next code commit.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.